Good morning. My name is Mark Kennis, and I'm one of the co-founders of Pitt Street Research and Stocks Down Under. Recently, we gave a presentation at the Australian Investors Association about the global chip industry. And because it wasn't recorded or webcast, we thought it made sense to record it for our subscribers and for anyone else who is interested. So let's go. This presentation will take us through a journey through semiconductor land, basically. A lot has happened. We've had a trade war since a couple of years. And the strength of China these days when it comes to chip manufacturing, and also the threat it poses potentially to Taiwan, is leading to a whole range of implications for the semiconductor industry. So we'll take a look at that today. And well, this is our disclaimer. Have a quick look. By the way, it's general advice only, so we don't do any it's personal advice. So keep that in mind when we talk about stocks later on. But the key takeaway from this presentation should be that this industry has become of great strategic importance in the last sort of 5 to 10 years. And China has become a real big player in this space. And so that's got a lot of Western governments worried. And also, like I said earlier, the perceived plans for Taiwan in the next couple of years, that is already starting to have a major impact in the semiconductor industry. So that's what you need to take away from today. And we'll look at the specifics and how this plays out for individual companies. But that's sort of the overarching thesis, that China has become a very dominant player in this space, and that's having major repercussions. All right, so the agenda for this presentation is we'll set the scene first for the semiconductor industry. We'll have a look at how exactly the strategic status quo is being challenged by China specifically, and how countries like the US and the EU, Korea, Japan, Taiwan are responding to that. And in that environment, which stocks we like. So starting off by setting the scene in the semiconductor industry, it's quite a complicated space, and so we'll talk about a few sort of basics of it. We'll try not to make it too complicated or high level, but we'll keep it high level. But yeah, there's a lot to sort of look at and take into account. So we'll start off by just having a look. So what is a semiconductor actually? Well, semiconductors are really small devices that are built on materials, usually silicon, that can be either tweaked to be insulators or to be very conductive. And depending on the sort of impurities that you add to the material, you can tweak that resistance of the material itself. And that's, in a nutshell, how you build transistors, which are the smallest building blocks of chips. There is a resistance in the transistor itself. You can tweak that by electric charge, and transistors themselves can hold a value. You can switch between them. You amplify signals. You can do all sorts of stuff with them. But what you need to know about them is there's in the most modern chips these days, there's millions and billions of them, and we'll have a look at that as well. The way they're built, so look at that picture at the bottom there, it almost looks like a skyscraper, right? So these chips are built layer by layer in processes that can take up to 4 months and up to 1,000 process steps. And some of these chips can have more than 100 layers. So it's really complicated stuff. And if you then look at how this has progressed over the years, the latest chip by IBM, 2 nanometer chip, which isn't in mass production, it's really a laboratory type product right now. But that's got 333 million transistors per square millimeter. So just to give you a sense of how small all these chips are, or these transistors are. And just to give you a sense, I mentioned 2 nanometers. So a nanometer is 1/1000th of a meter, and it's really the resolution or the line width of the chip circuitry itself. So you've got all these lines on these chips in each layer. And nanometer is the metric that is used for that. It's abbreviated nm. So like I said, it's 1/1000th of a meter or 1/1,000,000th of a millimeter. So just make a millimeter with your fingers, and then just imagine there's a 1 million lines can squeeze into that, or 1 million nanometers can squeeze into that millimeter. And to put this in perspective, the human hair is 100,000 nanometers wide. So you can see your human hair, obviously. But a nanometer is 100,000th of that. And to make it even more mind-blowing, consider that your hair right now, if you've got hair, by the way, but your hair grows on average at 9.5 nanometers per second, right? So each second, the amount that your hair growth is about 3 times as long as the most modern chips, the resolution of the most modern chips today, which is at 3 nanometers. So Samsung and TSMC are about to start 3 nanometer production, and that's the resolution, the line width of the circuitry. But your hair grows, give it about 3 times as fast as that. So it's really mind-blowing sometimes when you start to think about this. Now, what does the chip look like on the inside? At the bottom there, you see a very old chip. By the way, it's not modern by any means, but you can see the core of the chip is inside the black stuff. The chip is manufactured in what they call the front-end process. That's a square in the middle, if you look at the picture on the right. And it's got connections to the outside. And then also the black stuff, that's resin, and it's really to make sure that static electricity doesn't impact the chip itself. And so that's on the left, that picture, that's how we recognize a chip, right? It's just a black square most of the time, but this is what it looks like on the inside. Now, you've got a whole range of different types of semiconductors. The biggest 2 groups are logic chips. They're used to process analog and digital data. So examples are CPUs that you will find in laptops, computers, mobile phones, and a whole bunch of other products, because they're sort of the brains of a device. You've got GPUs, graphics processors, and these traditionally were used for video, so for your screens especially. But since about 5-6 years, the Bitcoin miners found that they can use GPUs for Bitcoin mining really efficiently. So that's taken off in a big way, and NVIDIA is the dominant player in that space. They've seen a massive increase in their revenues and also share price since about 4 years ago. There's also a group of processors called the neural processing units, and this is a newer generation. It's small still, but that's up and coming, and there's a few companies that you need to keep your eye on in that space. The other big group of chips is memory chips. So we're looking at, within that space, 2 different types. DRAM, that's basically the workhorse, the working component of laptops and computers. That's where the data that is used as the computers are working, that's where that particular data is stored for that particular action. So let's say PowerPoint or Word, you're working on that on a laptop. A lot of that data is stored in DRAM, and it's what they call volatile. So as soon as you unplug your computer, that data will be gone. As opposed to flash memory, which is non-volatile. So that retains the power when retains the values when the power is switched off. So you find that a lot in, for instance, your mobile phone to store your photos or your videos. You can find it in laptops these days, so it boots up your laptop really quickly. And there's a whole range of other products where flash memory is used. So these are the 2 main groups, logic chips and memory chips, and memory is divided into DRAM and into flash memory. Then let's have a quick look at the players. We're still setting the scene, right, for this industry. So who are the players in this space? Well, you've got what they call the integrated device manufacturers, the IDMs. And these are companies that do all of the work from design of the chip to manufacturing to testing. They do all of that stuff in-house. So the well-known names are Intel, for instance, NXP, which is the former Philips Semiconductors. You've got ST Micro, you've got Samsung in Korea, obviously, IBM, Micron, Texas Instruments, there's a whole bunch of them. So that's what they call the IDMs. They do everything from A to Z most of the time, although they're also sourcing more and more work to what is known as the foundry. Foundry is a chip manufacturer that does work for third parties. So they have their facilities, or fabs as they call them, and basically they fulfill orders for other companies. Could be chip companies, could be electronics companies. And so they do all the manufacturing and the testing. And these days, compared to say 20 years ago, foundries also do a lot more of the design work. They've got entire IP libraries that customers can source. And the big names there are TSMC, Global Foundries, UMC, that's also in Taiwan, SMIC in China, Samsung, and also Intel. And that's quite new actually, because Intel is not a foundry. Originally it's an IDM, but it's noticed that in the last sort of 10 years, it's lagged behind the likes of TSMC. And so Intel is now planning to become to set up Intel Foundry services. So we'll have an arm specifically dedicated to helping other companies manufacture their chips. It's still early days for that, so time will tell if this strategy is going to work. We'll probably need 2 or 3 more years to see if it's actually working. But that's the latest kid on the block when it comes to purely foundry services. And then lastly, we've got the fabless chip companies. So these are companies that don't have their own production facilities. They don't have their own fabs, but they do the design and the testing of the chips, and they outsource the actual production. So an example is Apple. Apple doesn't have a chip factory, but it does design a lot of their own chips. Same for Qualcomm, NVIDIA, the graphics card company that I mentioned. Broadcom, ARM, that's unlisted. Actually, there might be a chance that will be relisted again because SoftBank needs to get rid of it. So these are some of the names in the fabless space. So they outsource their production mainly to the foundries, and so that's in a nutshell the ecosystem there. So you've got basically 3 groups when it comes to the actual chip companies. Well, then we need to look at what's equally important, and that's semiconductor manufacturing equipment. Because without tools, without equipment, no one can actually make a semiconductor. So, and that in itself is a big industry. So I won't go into every detail of this slide because it's pretty complicated. But what you need to know is that starting on the left, you've got this sort of like a sausage roll almost of silicon, the silicon ingot, as they call it. That is sliced up into individual wafers that are then grinded down to be really smooth and also polished. They then go into the production process where the use of a range of different gases is used to build up these layers of each chip. And the most important step, as far as I'm concerned, is the lithography step, which is circled there, because in essence, that's where the design of the chip gets printed on the wafer, again, in layer by layer by layer. So if you look at that little circle there, you can see the reticle, the mask. That's where the design of a particular layer is in. A laser light shines through that and onto a lens to further narrow the light beam itself onto the wafer. And the wafer they can be up to 300 millimeters, so that's the biggest one. But you also have wafers of 200 millimeter and smaller, depending on the type of product that you're manufacturing. But what you need to know is that on each wafer, as you see in the bottom right corner, there can be hundreds or even thousands of chips on one particular wafer. So the exposure that is done with the laser light in the lithography step that you see up there, that can be done, depending on how many chips there are on the wafer, that can be done from a few dozen times to 1,000 times. So you can imagine that process needs to be really quick as well. Now, once that exposure stage has been done, chip goes through a number, or the wafer goes, I should say, goes through a number of steps where there's more gases introduced to, for instance, clean up the residue that you don't want. But what you need to know here is that process, that circle there, the chip can go through that even up, up to a couple of hundred times to build up the chip layer by layer. Once that's done, it goes to what they call the back-end process. And that's basically, again, to the bottom right corner there, where you've got the chips completed on the wafer, but now the chips need to be cut out of that wafer individually. So you get all these, the little squares basically. And that's called slicing and dicing. And that most of that is done in low-cost countries like Malaysia. So that's what is considered the back-end process of chip manufacturing. So you've got front-end and back-end, and it's a clear distinction between the two. So when we look at chip equipment companies, there's a couple of groups. There's a few really big companies in this space that that provide deposition tools, for instance, atomic layer deposition, chemical vapor deposition. There's a few others. Other types of deposition, but you've got polishing, etch, wafer inspection, and the big players there are Tokyo Electron in Japan. You've got Applied Materials and Lam Research in the US, and there's a smaller player, but not to be dismissed because they actually are quite innovative. ASM International, and ASM International was the original founder, together with Philips Electronics, of ASML. And in this presentation, we'll talk a lot about ASML. So those are the main players when it comes to deposition tools and polishing and etching. Looking at lithography, which I earlier said is probably the biggest, the most critical step in chip manufacturing. There's a company that stands out, and I've mentioned the name already. It's called ASML, a company in the Netherlands, founded in the mid-'80s and listed on the exchange in the early '90s on Euronext Amsterdam. And at that time, this was a really small company, and there were two key players, Canon and Nikon, that owned most of the market for lithography. But over the last sort of 30, 35 years, ASML has risen to become an extremely dominant player. And to give you an idea, the most advanced tools for lithography are called extreme ultraviolet tools, EUV, and ASML is a monopolist in that space. It has 100% market share. You can say that Canon and Nikon a long time ago gave up or never even decided to pursue research into EUV because it's so complex and so expensive. So that's one aspect. So the most advanced tools, it's a monopolist. But even in the less advanced tools, and these are called deep UV, deep ultraviolet tools, it's got an 80% market share. So even in that space, it's basically blown Canon and Nikon out of the water. I think Canon these days is really small. So that's why I made the logo a bit smaller than Nikon. But it's got 80% share in that market too. And so I think that's really critical. And this is something that you need to remember as we move through this presentation. Lastly, I just wanted to mention two equipment stocks on the ASX, and we'll go into a bit more detail later on, but it's Pivotal Systems and Revasem. Both are based in California in the US, but they've got a listing on the ASX, quite innovative. Pivotal supplies all of the three big players in deposition. So the three up there, Tokyo Electron, Applied Materials, and Lam, and also ASMI. It's been qualified at the big three, at the OEMs. Revasem is a player that is specifically trying to capture the rise of, for instance, electric vehicles, because the equipment they sell is specifically suited to silicon carbide chips, which are in high demand for power management, power electronics. And again, we'll talk about that a little bit later on. So to summarize the overall landscape, starting on the left, you've got the equipment companies, including ASML, Applied Materials, Tokyo Electron, etc. They supply the chip manufacturers, the IDMs and the foundries, the companies that actually have manufacturing facilities, and they sell to their customers, which could be the fabless chip companies like the Apples of this world, but also automotive companies and automotive OEMs. So there's companies that need chips and then put them in modules and sell that to auto companies. But there's electronics companies as well. There's a whole range of companies that need chips, obviously. And the final stage is that's getting sold to us, you and I, the consumer, or to businesses for a whole range of products. And the interesting thing here is that what they call the proliferation of semiconductors has gone really fast. And you see these chips in more and more products these days. And going forward up to, I think, 2030, the latest forecasts are for the current size of the market to double. So we're looking at about 8 years. And we'll have a doubling of the size of the semiconductor market. So that's really interesting. And here you can see it in the growth numbers really for semiconductor sales. So this chart goes back all the way to 1987, and you can see that nice growth curve. You need to remember that this industry is notoriously cyclical. So it's got big up and downs, boom and bust cycles. But overall, if you look through the cycle over the last 30 years, it's grown by close to 9% on average to about 600 billion US dollars last year. So that's a huge growth rate, obviously. And the interesting thing in this chart, if you look towards the end there, we're already sort of getting to a new upcycle when COVID hit. So we were getting to situations where we're starting to see certain capacity shortages, and then COVID hit, and all of a sudden people wanted new stuff for at home, new laptops, new mobile phones, new gadgets, and you see that massive spike in chip sales. And the interesting thing is, around this time last year, we started to get the first sounds coming out of the industry, out of chip equipment companies, that they were seeing shortages for the chips that are used in the machines to build chips. So it was a virtuous circle almost. And in any case, we're looking at where we are now with all these interest rate hikes. We're seeing a clear cooling off of semiconductor demand. TSMC the other day had very good results for the past quarter, and it's seeing still a very strong quarter ahead. But overall, it's noticing cancellations by orders, and there's a few other chip companies that are noticing that now. So by the end of this year, most of the shortages that we've seen in semiconductors will be a thing of the past, I suspect. Now, another development that you need to keep in mind when we talk about how China has evolved as a major powerhouse over the last couple of years is the fact that a lot of chip production shifted from the Western countries, so the US especially, and Europe, to the East, including China, including Taiwan and South Korea. And you can see in the chart there, China has become a very dominant factor and is expected to grow even further in the next 8 years through 2030. And that, of course, goes hand in hand with the role that the traditional chip countries have played or are playing now, because basically what you're seeing is that the dominance of the US and Europe and Japan actually is coming down quite substantially. And so that whole balance of power has shifted to the East, and mainly, again, Korea, China, and Taiwan. And the same is true for semiconductor equipment. So that sector, equipment sales grew 44% last year, so a massive growth rate. But if you look at the top three countries, China, Korea, Taiwan, again, are the dominant factors here. Big numbers from 2020 to 2021, and the growth rates there, 45%, 55%, 58% growth in equipment sales to these countries. And at the same time, look at North America and Europe. And even Japan, the equipment sales below 10 billion last year, and also the growth rates are a lot lower than what we see for the other countries. So that's setting the scene. That's what's happened so far. But we argue that the status quo in this chip industry, is being challenged. So what's going on? Well, the new kid on the block is no longer a kid. China is increasingly making big moves in this industry. It's become a powerhouse in the last 10 years. And if you look at what's happening in general with China, so not just economically, but it's been flexing its muscles in globally, so politically, economically, and also militarily. If you look at what's happened in, for instance, Solomon Islands recently with that deal, or these little atolls in the South China Sea that are being transformed into military bases. So China is becoming increasingly vocal and powerful in a number of respects. And so if you look at what's happening to chip production, and again, chip production is growing fast. But chips are used in more and more different products that may not have used as many chips before, or may not have used chips at all previously. So it's flexing its muscles. It's becoming a powerhouse. And Taiwan especially is being seen by Western governments as on China's to-do list. And when I say to-do list, that can be different things. But one thing is for certain, China is more and more interested in Taiwan. It always was, but we think it's sort of culminating. There's more and more interest on the part of China to actually potentially make a move on Taiwan. We think that's absolutely not beyond the realm of possibilities within the next 3 to 5 years. So why is Taiwan so important? Well, apart from the political stuff, I'm not a political analyst, but Taiwan has been regarded as a renegade province for a long time, for about 70, 80 years. Now, economically, Taiwan is home to a very advanced chip manufacturer called TSMC. And you may have heard of that name. It's the biggest foundry. So if you look at the chart on the left, that's just a ranking of chip companies in general. So you can see Samsung is at the biggest one. Intel, TSMC, SK Hynix, Micron, Qualcomm, all large companies. TSMC is number 3 there. But if you look at the chart on the right, you can see that the foundry business, when it comes to foundry, so that particular sub-segment within chip manufacturing, Taiwan is huge, and TSMC accounts for 54%. This is in 2020, 54% of sales. UMC, the other Taiwanese company, accounts for about 6 or 7%, but obviously TSMC is a big fish here. And so that is in itself is very interesting for a country, and we'll talk about that, a country like China that is increasingly being restricted in terms of what sort of technology other countries are allowed to export to China. But first, let's have a quick look at TSMC. So the story of the foundries goes back about 40 years, 30 to 40 years. And back in the day, and I've followed this industry from about the mid-90s onwards, but back then, these foundries were not sort of leading edge at all. They did work for third parties, and they weren't very advanced. The most advanced chip companies back then were the likes of Intel, for instance. But the foundries, including TSMC, they've basically transformed from sort of trailing edge small players to leading edge chip foundries, where the leading edge refers to the technology that they have in-house. So they're no longer the sort of less sophisticated players. They're really at the forefront of chip manufacturing, and that's evidenced by the fact that Samsung and TSMC are preparing to start producing at 3 nanometers shortly, and they'll be the first ones to do that. So that's one that's special about TSMC. But the other thing is, TSMC's got access to advanced manufacturing equipment that China doesn't have access to. And specifically, this is ASML, so lithography equipment. And this is crucial in a number of respects. But let's first talk about what exactly, in a bit more detail, what lithography is and why it's so crucial. So if you remember the slide I showed earlier with the entire manufacturing process, this slide zooms in on lithography especially. So in a nutshell, if you look at the left, the mask is really where the chip design for a specific layer is in. So the mask is used to shine a laser light through. That is then using multiple lenses. That beam of light is projected onto the wafer. And the way this has gone over the last sort of 40 years is that the capabilities of these machines has really been to make smaller and smaller chips. And in order to do that, you need basically do fundamental physics research to come up with new improvements and new innovations in these systems. And ASML is basically the only game in town for advanced lithography. And I mentioned EUV earlier. Extreme ultraviolet is the most advanced technology around at this stage. The company's got 100% market share. And the next generation of these machines, high NA EUVs coming out, is already ready to be shipped, basically. And production should start maybe in 2 years or so. And the company's got 80% share in older generation deep ultraviolet lithography, like I mentioned earlier. But what's so special about these technologies is that, and now I put down I gave you a few examples there at the bottom, but it's basically fundamental physics research that you need to do in order to manufacture these tools. So in this case, for instance, to get the EUV light going, a laser is fired 50,000 times per second at a drop of tin, which then vaporizes. So there's actually 2 shots with the laser. The first shot actually flattens the drop of tin, and the second shot vaporizes it, and that plasma actually produces the EUV light at a wavelength of 13.5 nanometers. That light, and you can see it on the left there, the purple, that light is then guided onto the mask where the design of that particular layer of the chip is, and then onto the wafer stage. And that wafer stage is positioned underneath the light at 1/4 nanometer accuracy. So just try to get your head around how small that is to correct that. And that wafer stage that holds the wafer is correcting its position 20,000 times per second. So it just goes to show how advanced you have to be in terms of your technologies to actually get to make a product like this. And it also shows that it also gives an indication of why the US especially is very reluctant to see this sort of technology fall into Chinese hands, basically. So this is EUV, extreme ultraviolet. These machines are so big, they take 3 Boeing 747s to transport to the client, just to give you an idea. Yeah, this is basically what we're seeing now. The war in semiconductor land is being waged around these sorts of systems. So a couple of years ago, when Trump was still in office, the Trump administration was leaning very heavily on the Dutch government not to grant ASML export licenses of these tools to China. And they succeeded. So ASML hasn't been allowed to export these machines to China, which means that China, without EUV tools, is not able to manufacture leading edge chips. And that means below 14 nanometers. So they've got older machines from ASML. They've received those, ever since ASML was basically in production. They've been able to import those systems from the Netherlands. So deep ultraviolet has been in use at China for decades. But EUV, which is the next generation, is not being allowed, is not being sold to China because of these export restrictions. And now the interesting thing is, and this happened just a week or two ago, the current U.S. government is now leaning on the Dutch government to ban the exports of deep ultraviolet tools to China as well. And so, of course, there is a very large installed base of deep UV tools in China, but it would mean that China would be significantly restricted in expanding its production capacity. And it would need to rely on, say, Nikon for particular deep UV tools as well. And so if this actually happens, this would be a major blow to China when it comes to their ambitions in chip manufacturing, because without the latest deep UV tools, it will be very hard to expand their production capacity. So they might try to get some older systems on the second-hand market, because believe it or not, there is a used or second-hand market for all these sorts of tools. But you could never get the amount of tools you needed to actually keep up with your production requirements. So this is a very, very big step if it happens. A very big blow, I'd say, to China. And so this brings us back to, okay, so why does China have its eyes on Taiwan? Well, one thing is ideology, but I won't go into that. That's more of a political issue. But I think it's an existential issue as well in the long term. And by existential, I mean existential for its chip industry. Because if ASML is also banned from exporting deep UV tools to China, China will gradually be starved of the ability to manufacture advanced chips. Of course, it can manufacture below 20 meters today, because with the old deep UV tools, it can do that. But going forward, say looking at 10 years, that would be a major catastrophe because you can't expand your production capacity anymore. So it needs an alternative source of leading edge, but also trailing edge technology for chip production. Now, there's a company, Shanghai Microelectronics, that is been doing making lithography tools, but they can only do it at 90 nanometers to date. And I heard some rumors that they actually are now preparing to ship a 28 nanometer tool, which would be a significant improvement, obviously. I think the source for these tools is probably the existing deep UV tools that ASML exported to China. So my guess is they basically opened up a tool and started to copy all the parts in it. That's one thing. So actually manufacturing at 90 nanometers or even 28 nanometers, if the rumors are true, that's one thing. But the key is to do it at high volumes, right? So the most advanced tools, deep UV tools, can process 200 wafers an hour. And so I'm not certain that Shanghai Microelectronics can do that. But anyway, it's an alternate source for deep UV tools. But look, I think I would expect that the US government is also leaning on Japan, so that Nikon is not allowed to export any deep UV tools either. So that's what what all the fuss is about, because China could use its leverage, its current leverage in the chip industry, because it's a major manufacturer, right? Not of the most advanced chips, but of somewhat older chips. They could leverage that production in a potential conflict situation in a similar way that Russia is now withholding gas from Europe. China could potentially, in a conflict situation, maybe involving Taiwan, it could refrain from selling these chips to Western countries. And that's got a lot of people spooked, because China has become very dominant. If all of a sudden the supply of chips from China stops, that is a big issue for Western countries. So that's one aspect. The other thing is that we, like I said earlier, we expect China may make a move on Taiwan sooner rather than later. And that could give it access to EUV tools that are working right now in TSMC's facilities in Taiwan. And so both things pose a major threat to Western countries, because both scenarios would basically restrict the free flow of chips to the Western world. So how are countries responding to these threats? And actually, the chip that Biden is holding there is a chip manufactured by Skywater, which is Weebit Nano's partner, the first commercial client, I should say, for Weebit Nano. And many people will know Weebit Nano. It's listed on the ASX. Definitely worth having a look at that one. Just an interesting fact that Biden is holding one of their wafers. So how have countries responded? Well, the United States has been working on the so-called CHIPS Act. It's a $52 billion initiative over 5 years to stimulate domestic chip production in the US. So it's also to do with R&D, but especially production needs to be done more at home is what the US is thinking, and it's been pushing local players like Intel, but also the likes of TSMC to set up more chip fabs in the US. This in turn obviously would limit, so once these fabs are up and running, this would limit the dependency on China and also Taiwan for chip production. And it would make the country more independent from these, independent of these two countries. Now the problem is this CHIPS Act still hasn't passed in the US, despite bipartisan support. They're still bickering about certain stuff, and actually both TSMC and Intel have said, look, we need this act ratified because without it we won't be moving forward because it's just too expensive to manufacture in the United States without any subsidies. Turns out Korea and Taiwan are a lot cheaper than the US to do that. So we're still waiting for that. And every delay in this CHIPS Act will also delay the ramping up of production domestically in the US. Europe has done something similar, the European CHIPS Act. It's a bit smaller in scope, and it's public-private investments combined. It's the same focus, really, R&D, and get more production in Europe going. And actually, global foundries, together with ST Micro, have planned a new fab in France, in Crolles, which is sort of the French epicenter for chip research and chip manufacturing. So there are initiatives that are moving forward, but the plan is to have many more companies set up shop in Europe or expand existing facilities. So for instance, Intel is looking at Germany, TSMC is looking to set up shop in the EU as well. So all these sorts of initiatives are really meant to be less dependent on Taiwan and on China. And I think, give it some time, but I think it will happen. And Europe and the US, you know, from a political point of view, it takes time to get stuff done, but I think it will get done because it's just too important not to do it. And of course, China itself, look at the last one there. China's been spending about 150 billion, or the plan was to spend 150 billion over 10 years. It's into the second or third year of that to boost domestic the domestic chip industry. So from the manufacturing equipment to the actual production to R&D, all that sort of thing. And it's got big ambitions there. And the key focus obviously will be lithography, because again, that's the key step in the whole process. Korea is not on here. Their plan is actually the largest of all. It's more than $400 billion over 10 years, 10 or 15 years. And really, again, to bolster the domestic chip manufacturing. So in this environment, which stocks do we like? Because that, at the end of the day, is what it boils down to for us as investors. So in the mega cap space, as we like to call it, it's ASML, NVIDIA, and TSMC, the really big plays that we like. And on the ASX, we like Weebit Nano, BrainChip, Revasm, and Pivotal Systems. And just for full disclosure, we own Weebit Nano, BrainChip. We've owned Revasm in the past. So full disclosure, we own some of these stocks. And I'm looking to get into ASML actually again, because I think it's a brilliant stock. It's probably the best company that you've never heard of. I did this presentation last week, and I just asked the people in the audience how many people actually heard of ASML, and I think it was less than 15% of people that knew this company. I said, look, if you've got stocks like Apple or Tesla in your portfolio, you definitely need some of this, because it's without ASML, Apple or Tesla couldn't actually sell their products because no chip would be produced that could do what it needs to do, what Apple and Tesla needed to do. So what's to like about ASML? Well, we've gone through a number of things already. It's a monopolist for EUV. No manufacturer can go without ASML if you want to be competitive, cost competitive. And we think growth in the semiconductor industry will only continue, not just in the next 10 years, but in the next 50 years, I suspect. And looking at what's happened since the sell down started in the tech space globally, since the tech crunch, we think the valuation is really attractive. So we typically look at not just EV/EBITDA, but we try to relate that to EBITDA growth for the next financial year. So if you do that for ASML, based on consensus estimates, you end up with a number around 0.74, which I think is pretty attractive. Anything below 1 is attractive. Anything above 1 can be considered expensive. And the lower you go in this case, the more attractive it is. So we really like it. If you look at the chart there, you can see the long-term uptrend, and you can also see the chart on the right there, the exuberance during COVID, and now the stock is sort of correcting back. Right now, it's sort of in the middle of that long-term range. But if you can pick this stock up around $400 or below, I think you'll be doing yourself a really big favor, 10 years from now. The big risk here, obviously, for ASML is that if the China ban for deep UV systems goes ahead, that will have about a 15% impact on revenues on the top line. So you may see estimates come down if that ban actually materializes. But yeah, we'll see what happens. Even if that happens, I still quite like the company a lot. So you may have a short-term effect in the share price, but we'll see what happens. This one is one for the long-term holders, for not just for people that like technology. For any portfolio, I think this should be a core holding. NVIDIA. So these guys are market leaders in graphic chips. Originally purely graphics chips, but the chips themselves have been used for more and more other stuff, other things than display, to put it simply. So like I said earlier, Bitcoin miners found that you can use these chips for very efficient Bitcoin mining. And NVIDIA is sort of diversified into other areas as well. So high performance computing. So these chips are being used in data centers, but also in automotive, industrial crypto mining, as I mentioned. So there's a whole range of products that this company is tailoring to. And if you look at the expectations, consensus estimates again from S&P, the compound average growth rate of revenue is expected to be 18% in the next 3 years. So that's pretty attractive. And again, looking at the valuation, EV/EBITDA to EBITDA growth of 0.78. So I'd say that's pretty interesting. And this one has actually come down to the lower end of its accelerated growth path there for the share price. If you look at the charts on the top left, you can see the long-term growth, but a couple of years ago, especially around the time when the Bitcoin miners figured out, hey, these are interesting chips for Bitcoin mining, you can see an acceleration in the share price there. And that's now down to the lower end of that range. So if the tech crunch is sort of the big move in technology in terms of share prices is behind us, which it might be, yeah, right now this could be an interesting stock at the lower end of that range. The big risk here is more general in nature, not specific to NVIDIA, but if we get the current slowdown that we're seeing, if that is stronger than we expect and that lasts well into towards the end of next year, this company will see its impact on the share price as well. So that's something to keep in mind. So lastly, when we look at the big caps, it's TSMC. It's the world's leading chip foundry. Well, we've talked a lot about it. What I'd say here, looking at the risk for this company, is really any potential play China makes for Taiwan, because if that happens, then all bets are off, really. And so that's what you need to keep in mind. If it happens, we don't know. When it happens, we don't know. But there's a good chance that it will happen. And in that case, yeah, it's really a tricky one. But until then, and that's the best we can say, really, I think. And again, it's all general advice that we give. But until then, this is the best stock to own in the foundry space. You can see a similar pattern in the share price chart there. Long-term uptrend, some exuberance for COVID, and then it's coming back down the middle of the range now of the uptrend. And so, depending on where we go in the next couple of months, this could be really good buying opportunities for people that like the leading foundry in the world. Then finally, some stocks listed on the ASX, stocks that we really like. I won't go into too much detail because we've covered all these stocks with Pitt Street Research. So go to the pittstreetresearch.com website and you can find all this research. It's really downloadable. So have a read of that. But we like Weebit Nano specifically because it's the most advanced ReRAM player. It's about to commercialize starting early next year, hopefully, when the qualification at Skywater, its first commercial customer, is completed. Market cap is below $500 million Aussie dollars, which I think is low given what the potential is for this company. So the key risk is that the qualification at Skywater will potentially fail. I think that's a really small risk because it's not binary anymore, this technology. So I think it's a small risk, but I just need to mention it. That's one of the stocks that we really like. We own stock ourselves, so as a disclosure. Brain chip, I don't think that needs a lot of introduction because this is probably the most discussed chip stock on the ASX in the past 2 years. It's really popular in Australia. It's popular overseas as well. What you need to know is that Brain chip has developed Akida, a spiking neural network chip that can function without any sort of internet connection. It can learn without connections to basically the cloud, and it can make decisions autonomously, and it can learn autonomously, and all the while using very low power. So power consumption is really small, and this chip has got huge potential in our view. And the market cap right now is below 2 billion. But yeah, there's so much opportunity, so much potential for this one that down the line we see this go a lot higher. Again, I need to mention a risk here, or two risks, that you get better competing technologies. Of course, a lot of companies are working on artificial intelligence. Mostly it's been done in software, but there's chip companies working on it as well, but not to the extent that Brain chip has. So I think, yes, there is risk that you find other technologies, but I think the head start Brain chip's got is pretty big. Yeah, again, we need to mention the risks here, but I think it's very manageable. And I think this marketplace, say 10 years from now, is so big that there is room for a lot of players in this space. Well, then Revasem and Pivotal, two chip equipment companies. They sell equipment that is used to manufacture chips. Revasem, like I said earlier, sells tools that are used to grind down and polish silicon carbide wafers. And these particular silicon carbide chips are used in electronic applications, so electric vehicles or solar inverters. The characteristics of the chip are really well suited to that. But silicon carbide is a very hard material. So if you want to grind and polish the wafers before they go into production, you need specialized tools. That's what Revasem does. We've written a lot about these. There's a few interviews on the Pitt Street Research website as well. So have a look at that. The risk here is that the uptake of silicon carbide chips is slower than expected, which I think is, again, it's a small risk because electric vehicles are here to stay. And I think the uptake is really strong. So I don't think that is a massive risk. But again, we need to mention that. Then looking at Pivotal Systems, Pivotal provides gas flow controllers to all of the major OEMs in the chip industry. And these gas flow controllers are used to regulate the flow of gas into reaction chambers where the wafers are being processed. So you have all sorts of gas being used in chip manufacturing, boron, oxygen, hydrogen, helium, all sorts of gases. And these guys have the modules that go into the equipment that regulate the flow of gas. It's really crucial that you get that right. And I think they're in a pretty good position to benefit from that in the next couple of years. Right now, we're waiting to see what the company will say at the half-yearly numbers. So we have the 4C coming up this month, and then next month in August, we'll get the half-yearly numbers. And we also expect some new guidance, a new outlook from the company. So we'll see what they say there. But the share price is down to 17 cents now. I think it's really good value. But look, Mr. Market pays or values companies, on a day-to-day basis. So you never know what's going to happen. So we'd advise people just to sit and wait what the company says. But yeah, purely looking at their ambitions and the product they have and the current market valuation, we think there's a big disconnect between the two. So that's why we like Pivotal Systems as well. So key takeaways. China is a key focus in the semiconductor industry these days. It's got the power to potentially withhold chips to Western countries in a conflict scenario, and it's got its eye on Taiwan. Both will seriously upset the world economy in general, but also the chip security to Western economies. That's why we're seeing all these initiatives of governments trying to get chip production back locally, especially Europe and the US, and that will have a profound impact also on chip equipment suppliers. And that's why we really like the chip equipment suppliers as well in this space. So that wraps up our presentation on the semiconductor industry. If you've got some time, take a look at stocksdownunder.com, the website, because we just launched a new product, Stocks Down Under Concierge, which basically gives you buy and sell alerts on ASX listed stocks. We'll give you a price target. We'll give you stop loss range as well. We tell you when to buy and when to sell. And this product is really well suited to people that don't like to read all our research, or don't want to do all our research, or don't have the time to do all that research. So it's really tailored to people that are a bit time constrained or just don't want to do any research into investing, but still want to invest. So we send out our alerts by email and SMS. And it's really, as far as we're concerned, really straightforward type of product. You can get a free trial on the website. Try this out for 3 months, see how you like it. No need to put in credit card details or anything. Just have a look, see what you like. You'll get a call from Peter, our customer service manager, who will talk you through the process. And it's no strings attached. If you don't like it, it just expires. So give it a shot. And with that, I thank you very much for your attention.